go back to the whiteboard, I think. So one more thing that we want to talk about today, and this is, so given little f of t, when does capital F of S exist? That's the one other question that we want to answer. So far, all of the functions that we've been doing have had Laplace transforms, right? I haven't given you anything where the integral diverged for all values of S or where we didn't get any sort of answer at all. But that isn't always true. Sometimes the Laplace transform doesn't exist. And so here's our theorem. It ends up that capital F of S exists if little f of t is of exponential order. I have to tell you what that means. Exponential order. So the Laplace transform exists if our function is of exponential order. I can write the R better there. Exponential order. Okay. There's a fancy definition in my notes. If I were, again, teaching this live, we would go through that. But here's the definition that you want. So the definition is that little f of t is of exponential order if the limit as t goes to infinity of little f of t over e to the c times t is less than infinity for any positive constant c. That's a mouthful. Let me say it again a couple of times while you're writing it down. Little f of t is of exponential order if the limit as t goes to infinity of little f of t over e to the ct is less than infinity for any positive constant c. One more time. F of t is of exponential order if the limit as t goes to infinity of little f of t over e to the ct is less than infinity for any positive constant c. Let's do an example, and then I'm going to put you into breakout rooms and you can do another example. So here's my first example. Little f of t is going to be t squared, and I want to know if this is of exponential order. So if I have my little f of t is t squared, I want to know whether this is of exponential order. So what I need to do is take the limit as t goes to infinity, t squared over e to the ct. Limit as t goes to infinity, t squared over e to the ct. I don't know what c is, but c is going to be some positive unspecified constant, some unspecified constant. Okay, if I do this, positive infinity on the top, and then the denominator, my exponent is two positive numbers multiplied together, right? Exponent is two positive numbers multiplied together. So my whole denominator also goes to positive infinity. Infinity over infinity. Thinking back to Calc 2, infinity over infinity is what? What type of form? Infinity over infinity. Stuart, that is...
Well, I was just going to say L'Hopital's rule.
You want to use L'Hopital's rule? Yup, Do we remember the fancy math name for what you get if you have infinity over infinity?
Like
people are now looking, at least the few of you that I can see, looking pensive. Any takers? Remember what that's called? You have to use L'Hopital's rule. Alright. Starts with an I.
Indeterminate?
Indeterminate form. Yep. So this is of indeterminate form, and I therefore need to use L'Hopital's rule. All right, so let's go ahead and use L'Hopital's rule. We will go, whoops, up over here. So if I use L'Hopital's rule, I get limit as t goes to infinity. Derivative of the top is 2t. Derivative of the bottom is c e to the ct. 2t over c e to the ct. If you plug in, you are going to get infinity over infinity again, because I still have a t in the top. So I'm going to have to use L'Hopital's rule one more time. So if I use L'Hopital's rule one more time, I'm going to get limit as t goes to infinity, 2 over c squared e to the ct. And that is 2 over positive infinity, which ends up equaling 0. 2 friends, infinity sticks of gum. Everybody's going to get 0 pieces of gum eventually. All right, so I evaluated this limit. I got 0. 0 is less than infinity. And so therefore my answer is yes, f of t equals t squared is of exponential order. And what that tells me is that the Laplace transform of t squared exists. That's good because we calculated it on Tuesday, but we're now guaranteed that the Laplace transform of t squared exists because I get a limit that's equal to 0. Okay, taking a pause, stopping to share my screen. Anything on that exponential order before I divide you back into breakout rooms and have you work on one more yourselves? Any questions on exponential order? Got the basic idea of exponential order there? Everybody good? Okay. All right, let me share my screen again. Here's the next one that I want you to work on, and then I'll divide you into breakout rooms. So here's my function. Little f of t is going to be e to the t squared this time. So e to the t squared. And what I want to know is little f of t of exponential order? So my f of t is e to the t squared, and I want to know whether little f of t is of exponential order. So you're going to need to do a limit, e to the t squared. All right, breakout rooms, here we go. Same ones as what you had before. So let's open up all the rooms. You should be able to hop in there. Just take a couple minutes, work through that one, see what you can come up with.